Okay, so first of all, thank you everyone for joining this training because at very end I informed you. So just it was about yesterday, if I'm not mistaken, I informed everybody to join this training, and we are going actually now to conduct the training for CYPE Connect. Okay, so as we know, CYPE Connect is a solution for analysis and design of simple to complex connections. CYPE Connect Steel. Okay, and as you can see here, so you can actually now go for all of this type of connections. Doesn't matter about the complexity, so you can go for connecting the let's say steel to wood and also steel to concrete. Okay, from different uh, directions. Okay, from 3 different directions, so you can do that. It is supporting the post-install anchorage as well, or anchors. Okay, so which means if you have the strengthening job or existing structure with the existing concrete column or concrete wall, and you want to drill the concrete block to add the steel member, so you can actually now use this software as well. And also it able to generate the drawing. Okay, so it doesn't matter again about the complexity of the let's say connection. So you can just, it is up to you. Okay, you can generate the drawing from any view that you want, and you can come up with a professional drawing. So I will show you quickly. And okay, and another thing is that there is actually no integration between CYPE 3D and CYPE Connect. So I know that all of you that right now joined to the session, you have the CYPE 3D as well. Okay, and assume that, for example, you have actually know this type of connection. Okay, or let's say, sorry, this structure. Okay, so if I show you this structure, this is actually just from one of our client. By the way, in CYPE 3D, you have a cool feature. Okay, so we call it layer management. Okay, so you can actually come up with the color of the members, and simply you can actually just divide them. For example, here, if I want to, for example, look at the let's say the UC 305 by 95, and I want to see the connection of the UC with the UB533 only. Okay, so you can actually now go there and then just activate actually this one, and then so you can filter it. Okay, so that's why actually now for CYPE 3D, whatever actually I trained you, it wasn't actually, I mean, about everything. Just I trained you about the flexibility and about actually the features that you have in the software, but definitely is not all. And that's why the rest we can actually leave it to you during your real project if you have any let's say requirements. So that's why we are saying that you need to ask questions. Okay, and just by having your question, so I mean slowly and let's say smoothly, I will show you different features that you have, but in a training, so it's not possible, to cover everything. Anyway, so let me just go back to layer management. Okay, so here, the thing that I have here, it is all about actually, this is structure that I have. If I want to show it, in the normal color, so here I can actually, just deactivate it, and then so I can see actually, just like this. In this model, okay, so I have, let's say, different type of connections that may not uh, possible to design it inside 3D. So that's why I can actually now just link my model, or let's say CYPE 3D model, to BIM Server Center. Okay, so already we talked about BIM Server Center with everybody as of you. Okay, so here I have my BIM Server Center. And if I go to the project page in my BIM Server Center that I have, so already I just upload this model to BIM Server Center. Okay, so regarding this, if you want to understand how to upload the BIM Server Center sorry, the model into BIM Server Center. So already I created a video in my YouTube channel. You can go to playlist, and from here, if I'm not mistaken, you can go to building information modeling. If I'm not mistaken, you can find it. You can find it here. Okay. So Bowen meeting. Yeah, here you have easy BIM collaboration using CYPE solutions. Here I discuss about the IFC uploader. Okay, so you can actually now watch this video. I think I need actually now to create one video about this integration as well. But I will show you here. Okay, assume that I want to open up, one of this model that I have. Maybe I can go to one of this model. Here I have actually no CYPE flag. Okay, let me just open up this model. This is also a funny shape that just I created last week for some demo purposes. Okay, if you look at the let's say this shell element. So here I just came up with this one, and also I run the buckling analysis. Okay, so you can actually do the buckling analysis for shell elements as well. Okay, so here I have it. You can actually see it like this. You can just look at the buckling shape. Okay, so here you have the scale, so maybe you can decrease the scale. Okay, so here you have it, and then so you can understand actually the let's say steel sheet that you have here has any problem with the buckling or not. Okay, but here, as you can see, under different load combination, I can do the buckling analysis, and here I can see that I don't have any problem because the buckling factor is less than 1. Okay, so here I have it. And then so let me just bring this model to BIM Server Center. Okay, so the procedure is like this. I will just go to BIM Server Center from CYPE 3D, and then here I select link. Okay, so right now, if you look at my BIM Server Center, I don't have such project in my project page. Okay, if I go to my project, okay, you see here the latest project that I have is the export option. You can create a project directly using BIM Server Center, new project, or I can go to CYPE 3D, which is here. I can click on project selection, and then from here, I will go to create new project. Just click on new project, and here I will name it with the same name as I have in CYPE 3D. I will say CYPE flag. Okay, and the owner is me. The type of project can be professional, educational, evaluation, or generic. So let me select professional. View options. So here you can actually now make it visible for all BIM Server Center users, okay, around the globe, or you can say not visible. Okay, but you can open the collaboration. Maybe later you want to invite some of your colleagues to this project, to develop this project, to work on this project. So that's why you can open the collaboration. And then here you have actually there's two options to review the contribution and also updated contributions. So then accept it. Okay, so I will accept. And then here, as you can see, this project or this site model right now is connected to site flag in BIM Server Center. If I accept this, and if I go back to my BIM Server Center and just refresh my browser, you will see that I have the new project with CYPE flag. Okay, so here I have CYPE flag. Now let me go to here. So the second step is to share the IFC file format into BIM Server Center using the share option. Okay, I will click on that. And again here, I will say that CYPE flag. Okay, so I have the same name. Look at here, I have the export forces to design connections. Okay, so before doing this, because here I didn't run the analysis to have the let's say to have the result. Okay, so I will just I run the buckling analysis, but also you can go for calculating the stress and stresses, and also to calculate the beam end forces or analysis forces. I just run the analysis, and that's it. So here I have it. And then if I look at the forces, for example, here I want to look at the for example, axial force of this member. You see here, I have actually know this. This is actually now huge axial force, okay? And now I have it, and then I will go to buckle, let's say BIM Server Center. Now I will share the forces, okay? So here I have the forces, and then site flag again, okay? Export forces to design connections, accept. Okay, and the last step is to consult. Okay, go to consult and then just check the option. Here you have another option. It is update the rotational stiffness of the element ends. What is this option? This option actually no is advanced option. Assume that you have this simple frame, okay, and then so you have the beam end forces, and definitely before designing the connections, okay, so here you have actually the stiffness of the let's say this beam and column, okay, and then here we have actually the rigidity. Assume that you don't have any releases, and then so you export the model to CYPE Connect Steel through BIM Server Center, and you design, for example, something like this. Okay, let's say this is actually the end plate, and then so here you have actually the beam. Here you specify the hunches, and then here you have actually some bolts. So this actually just add some additional stiffness to this joint. Okay, so that's why if you want to consider this one and then you want to update your CYPE 3D, so you can actually say that update the rotational stiffness of the element end, okay, to update the stiffness, okay, based on the let's say the connection behavior that you have, whether it is rigid connection or semi-rigid connection or hinge connection. Okay, so this is also a cool feature, but right now let me just uncheck this one. I want to only focus on CYPE Connect Steel. Okay, so now after doing the share and consult, I will go back to my BIM Server Center once again, and again refresh my BIM Server Center account. Okay, so now here I have actually the model, okay, and then so I want to focus on the, let's say the column, and I want to design the base plate, let's say. So what should I do? I will go to my site menu, and then here I have Site Connect. Just click on that. So the first procedure that I'm showing you right now is about the integration of CYPE 3D to CYPE Connect Steel, okay? And you have all the combinations, the sections, so you don't need to do or put any effort to get this information. So again, here I will say CYPE flag, okay, and then accept. So now I can go to the select project. If you want to start from scratch, any connection that you want to design, assume that you have the beam end forces from another company and they ask you to design the connection separately. Okay, so you need to uncheck this option, okay, and then accept, and then you will be able to design the connection from scratch. I will show you after this. But once you are integrating the CYPE 3D to CYPE Connect Steel, so you need to check this option, link to BIM Server Center project. And then from here, I can go to select project. Okay, so here I have CYPE flag. If you want to see the project, you can click on this search button here. Okay, so you can see this is here. Okay, and then accept. Okay, so just check this one. This is actually coming from consult. And then here you have the generate nodes automatically. So I always prefer to uncheck this option because I want to generate the nodes or connection location by myself, okay? And then accept. So once you accept this, you need to map the sections that you have, okay? So here I have actually the UB 1100, 400, 607. If I go back to here and if I go to describe, okay, so here you can see that I have the UB 1100, 400, 607. Okay, I have the same thing, and then so I will go to here, and also here I have some elements, which is actually now the plate. I'm not caring about this too much, but if you want to see the plate here, so here I have actually now this, let's say, simple steel plate here. It is FL 160 by 60. Okay, so this is also here, you have it. Okay, we are not caring about the shell. Okay, so we are going to design the connections and then accept. By the way, before accepting here also you have the cross section. If you want to change, okay, you can change it here. And here also you have the material, which is E250, the same material that you have here, okay? As you can see, E250, and then here E250. Later, if you want to change the material, you can do it inside Connect Steel. I will accept this. Okay, so now here I have it. I'm not caring about, all these members, but I want to care about the, let's say, the base plate design. Okay, so how you can do it? So here you can start creating the connection location or nodes for yourself, okay, using this option that you have here. As you can see here, you have the node, you have the connection, and here you have the analysis. Okay, so, and before that, you have the project. So if you go to the project category, so here you have the codes, you can click on the code. And from here, we are supporting the Euro code. And maybe, for Malaysia market, also we have the BS code as well. Okay, so you can look at the BS 5950 part 1. Okay, apart from, or let's say, along from many other international codes, including the American code and other, let's say, codes as well. This is for steel. Also for timber, we are supporting the Euro code, and for concrete. So here we are supporting again, different codes. Under concrete, we are not supporting the BS code right now, okay, so far, but we are supporting the EC 2 as well, okay? So let me, for this example, select everything as Eurocode and then accept. And here you have the libraries of the elements, okay? So here you have the material. You can go there and you can actually now add the material as much as you want. You can, for example, here click, just here, you can name it whatever you want, okay? So once you click on here, so then you can actually just go there and you can edit it, okay? So here you can just create the different material for yourself. You have actually the types of steel for bolts, anchors, let's say for concrete grades, for timber, types of timber, and also you have the dowels, you have the bolts, and also you have the screws, okay, for designing the steel to wood connection. And then here you have the elements, steel section library. So for example, here you have this sections by default. Here I cannot see, for example, the UB and UC. Okay, so I can go to this option, the last one, okay, and then click on this. So I can find it under European section ranges, okay, and then here I have the UB and UC, okay, and then accept. Okay, so here I can bring it here. By the way, this is under ruled section. So you have the I-beam section, you have the channel, you have the T section, you have the L section or angle, and also you have the plate. Okay, and if you change it to built-up section, so here, since built-up section is not a standard type section, so you can create it again for yourself. You can add it, and then from here you can add, built-up sections for yourself. And then you have the cold form. Okay, and again, if any of this cold form library or sections you cannot find, you can go there and you can bring it. Okay, and the last one is the tubular. So you have the CHS and also SHS or RHS kind of tubular sections. Okay, so let me go back to rule, and then here I have the I sections, and I added the UB and UC, and then accept. Okay, so you have the same thing here. For example, if you go to the anchor, and then from here you can go to edit, and then here you have different type of anchors with different, let's say, diameter, okay, with different codes. Okay, you can again edit it, you can add it for yourself. So everything is customizable. Okay, I will accept this. And this is actually, the library or or let's say the options to connect yourself to the manufacturing of the post-installed anchors. Okay, so for post-installed anchor, we are working actually now with different manufacturer like Hilti, like Fisher. Okay, so again, I will show you later. Okay, so now let me go to, after project category, let me go to the node category. So I want to create one node, just click on this, and then you can come here, okay, and then you can click on this let's say node, something like this, okay, this and this, and then you need to do right click, okay? So then here you have the column. And then here you have the information for this column. If you want to change the column grade, for example, you can say 275, okay? And maybe sometimes you have actually now the PB sections, okay? So you can go to built up sections, and then here also you can create the PB sections. If you go to initial depth, so here you can see that you have the options to generate the PB columns or rafters or beams, okay? So let me go back there to the section that we have from Site 3D. Okay, I don't need to do anything else here. So just everything is coming from Site 3D, and then I will accept it. So the node is here. Now I'm ready actually to uh, design the base plate, or let's say, the connection. But before going to the connection, which is here, you have also some other options. You can edit, okay? Assume that here, if you click on edit, you can click on this join. And maybe here you want to add one, for example, one additional member here, okay? You want to one additional member here. You can, just click on this add button here, okay? You can name it. You can say that, for example, member 2. Okay, here you have the member 2. And then so from here again, you can say that, the material and also the section, you can select it as UB section, maybe here. Okay, and then as you can see, the member is here. And then you are able to place the member at the right location, okay, using the local coordinate system that you have. As you can see here, you have the local coordinate system, and also here you have the local coordinate system as well. Okay, so you can here just shift it in the Z direction. So I will say that, for example, by 100, if I let me 600, okay, so I can shift it even, let's say 800. Okay, here you have the options, to go for different views. You have it from here. And then so I can also, shift it in the X direction. Okay, so here I can go to the X direction, and maybe here I can shift it by 400. Okay, so something like this. And then so here I have actually now my, let's say, new connection. Okay, so you can add members as much as you want. Okay, so again, you can go there and you can add, maybe you want to add another member, with the different angles here, different angles here. So just you can actually add it, and then here you have the, just the angles around the z-axis or around the xy plane. Okay, well, let me just delete the M2 just to let you know that actually what you can do with this. And then if sometimes you have actually a plenty of joints already you created, and then if you want to delete them, so you simply you can click on this option and then click on the joint and then do right click, so it will be removed. Okay, so here you have the undo and redo option, so you can click on undo, okay, to come back to the previous let's say step. And if you go to this option here, you have this small earth icon. You have the undo redo option again here. I suggest you to click on this and set it to the maximum value or maximum allowable value that you have, which is 20. By default, if I'm not mistaken, it should be 5, okay? If it is 20 is okay, but if it is 5 or any other number, make sure that, just put it in 20, which means if for any reason, if you made a mistake, um, you can actually 20 step go forward, 20 step go backward. Okay, so it is good, let's say, chance for us to save our time. So this is about the things. And then here you have actually the group. Maybe for group, let me just save this model. I will open up another file to show you. Okay, I will come back to this model. Let me open up this. Okay, you see here, I can actually now go to group. Right now here, I grouped, this, let's say, purlins to rafter connections, okay? And then here also, I have some other, let's say, same connections, but they are not under the same group, okay? If I click on that, you see here, only they are on the same group. I can add, okay? So for example, I can add this actually now to this group, okay? And then let me just, you see here, I cannot actually now add this to this group because, the connection is not similar, okay? But I can actually now add this one, and you see the software automatically understand this, okay? Because already I created, this groups. And then do right, let's say this one, okay? And then, so do right click, okay? Let me just once again select this one. Okay. Okay, so I just, add this one, this one, this one, this one, okay, with this one. Okay, and as you can see here right now, I grouped actually now this members. And if you want to add more connections, just as I told you, you can go to new. You see, for example, this purlins with this rafter, I can select this tree and then do right click, okay, and then accept. So I have another, let's say, connection here. Here you can see actually now the real structure. If you go to this view option, okay, so here you can also look at the access, okay, so here whatever actually now we could see under the CYPE flag, I brought it to CYPE Connect Steel, okay, so it was like this. But if you want to see the real section, so you can again go to view option, and then here you can say 3D model, okay, and then here you can see 3D model. And again, from here, again, I can add, this one, this one, this one. Let's say right click, accept. Okay, and again, this one, this one, this one, right click, accept. Okay, so here I have actually now this connections. And then, so I will go to, again, let's say, select this tree, and then so I can add it to this group. Okay, so right now they are under same group. As you can see here, they are all under the same group. Okay, so in this way, actually, no, you can group them, you can ungroup them, and then here, or you can tell the software to group it automatically. Okay, so this is actually now the, let's say, very fast method to group the similar connections. Okay, but those connections that we created, okay, for example, here, I don't have any connection. So that's why, the software doesn't group this and this. Okay, so you need to create it first. Okay, so let me go back to our connection. So black. Okay, and again here, if you want to see it, I can go to view option and then 3D model, and then here, so you have it. Okay, so this is the option. So I don't have any other connection to group them or ungroup them. And then, so later I will go to the connection category. So here I can click on edit. And then, so here I can click on this, let's say, connection that I created. So once you click on that, here you have different operation options, okay? You have the reference plane, you have the bar plate, adjust bar, trim section, end plate, lateral plate, trim plate, and so on and so forth, okay? So you have all these options to come up with your own, let's say, connection. If I accept this, let me accept this. So the first way I showed you to go to the connection is here. Just click on edit and then click on here. But also you can come here. You see this, the connection name is here. Okay, so from here also you have access, this is the shortcuts. Okay, you can edit it. For example, if I go there, simply I can edit, I can add the sections just I showed you earlier. You can, take a copy of this. Maybe you want to optimize it after, let's say, analyze it in the first round, you want to optimize it. Okay, you can do this. And then here you have the connection. Okay, so here you need to select the connection and then click on this connection, a small connection button. Okay, just click on that. And again, you will come to the same window. Okay, so here we are going to add the plate first. Okay, so I will go to add the plate. So just simply, I will click on the plate. And as you can see, the plate is here. Okay, if you want to rename the plate or whatever operation you are adding here, you can go to edit. Okay, and then here, for example, I will say base plate. Okay, and then accept. So here I have the base plate. And then, so the material, again, I will say it is 275. Okay, and the thickness for now, I can accept as 20. And here, I can go to different views that I have. Maybe I can go to this view. Okay, and I will go for example, 1,500. Okay, by 1,500. Okay, so this is the thing that maybe here I can make it lesser. Let's say, for example, something like this. Okay, you can press shift and press the mouse wheel. You can rotate your model very easily. Okay, so right now I have it here, but I need to provide the weld here. Okay, So to provide the weld, you have, let's say, several options. The first option that I can tell you, here, if I zoom in and if I go to transparent view, if you want to see the model and plates in the transparent view, so here you have the view option, okay? You can click on that. And then here, sections, which means members, okay? So I can just make it as transparent view. You see here, I have the transparent view. Again, if I go to the view option, I can go to the plate also. And then here also, I can say that this is the transparent view. You see here right now, the column is penetrated to the plate, okay? So if you want to use the weld option that you have here, which is very straightforward, okay? So you need to set the base plate exactly at the beneath of the column. So again, you can actually now use the local coordinate system in the Z direction. For example, I can just shift it down by -10 because here I have actually 20 and then I can bring it down by -10. Okay. And then, so if I go back to, let's say this 3D view, then I will go to at the weld. Okay. So here I will click on the weld. And here, by adding the operation, the software gives some kind of errors. Okay, so it means that the assigned section is not correct. So which means still we haven't assigned a correct, or let's say a proper section to proper plate. Okay, so here I want to say that the P1, which is the column here, section P1. Okay, and then here also I can say that let's say start with top plate. So should be welded to what? To base plate. Okay, so here I will say that to plate and then here to base plate. So now here you can see the weld applied and appeared here. Okay, so from here you can actually now just increase the weld size, for example, to 8. So here you have it. And then so just you can continue to add the weld, to this bottom flange and also to the web. So that's where you can actually now add 2 copy, 1, 2. Okay, and then so I can come to, let's say, weld 2. So here I will say that bottom flange, okay, and then for weld 3, I will say web. Okay, so that's it. Here you have it. So this is actually now the first way if you want to use the weld operation itself. Let me just uncheck this option. You can uncheck it without deleting the operations. Maybe later you want to use it again, okay? So that's why here I can say, okay, just I want to uncheck weld 1, 2, 3. And if I go back to the base plate, let me, just put it in the original location, which is I have the penetration. You see here, I have actually penetration of the column to the base plate. I can use another option, which is much easier, adjust bar. Okay, just click on adjust bar. And here you have the adjustment. Okay, so I want to adjust the, again, P1, which is the column, okay, with the plate, which is the end plate. Okay, so here, already adjusted. I don't have any penetration, you see here. And then, so here I have the weld, okay? Instead of creating 3 welds, I can use the adjustment. And then here, simply I can add the weld, simultaneously to the bottom flange, top flange, and also to the web. Here you have it, okay? To the phalanges and also to the webs. And here I will go back to the solid view. Okay, so here of column to the base plate. Now you can actually now go to the anchor if you want to add the concrete. Okay, so you can also add the concrete separately and then go to the anchor, but this is actually now useless approach. Okay, so why you want to add the concrete first and then add the anchor? However, if you use the anchor, automatically the concrete block is there, is attached to the anchor, and you can actually take advantage of the parametric option that you have. Okay, I will click on anchor. And then here, so the anchor should be connected to base plate. Okay, so here I will say base plate. And then here I can add the first anchor. Okay, so as soon as I add the anchor, so here you have the base plate. Sorry, you have the concrete block. Okay, so here you have the concrete block, and this is the anchor. Again, I can go to top view, and I can go to view option. I can just look at the transparent view, and this is actually now the anchor. Okay, so to place the anchors in the right location, assume that here I want to, again, you can look at the local coordinate system, okay? You have the local coordinate system in X and Y direction. That's why here you have the X and Y. Assume that I want to put, 3 bolts here, okay? This is in the X direction. I will say that, let me try by 1,250, okay? Okay, so it is too much, let's say 700, okay? A little bit lesser, 600, okay? So 650. Okay, so this is actually now the first location of the anchor. And then, so I will just add another one, okay? So let's say I want to put it here. I want to start from here. Now I need to go in the Y direction, okay? In the Y direction, I will also go for let me try 700, okay? Say 650, 550, and 450, okay? So I will select from here. So now I need to take a copy of this again. Very simply, I can take a copy of this. And then here, instead of, let's say 450, I will say 0. Okay, so here I have the second one. And again, so I can select this one and take a copy of this. And then here I will say minus 450. Okay, so here I have the location of this anchor. And now I can take a copy of this 3 operation or anchors. Okay, and then here you have the copy option. Just click on that. So this time here, I will say minus 650 to put it here, okay? Minus 650 to put it here, and minus 650 to put it here. Okay, so actually whatever I'm showing you here, okay, is about the, let's say base plate, and base plate can be designed in CYPE 3D itself, okay? So you don't need to use CYPE Connect Steel. But I want to show you actually, the possibility and let's say, the flexibility of the CYPE Connect Steel to work. Sometimes, in CYPE 3D, if you want to add the anchors, for example, very close to, let's say, this web of the column, if I'm not mistaken, Mr. V or Mr. Jin Ho actually asked me this question, okay? So if you use CYPE 3D, so CYPE 3D actually gives you an error because it strictly follows the code, okay? But here you can actually just take advantage of both options, the finite element analysis and let's say checking based on the code clauses, you can design it. Okay, so this is actually the advantage of CYPE Connect Steel compared or let's say over CYPE Connect Classic, which is you have it in CYPE 3D. Okay, so let me also add another 2 anchors here, one here and here. Okay, so I will take advantage of maybe this one. Okay, and then so make a copy of this, and then here I will say 0. Sorry, here I will say 0. Okay, so 0, and then I will put it here, and then so I will take a copy of this again, and here I will say minus 450, and then here I have it. Now I'm done actually with anchor locations. And now, so I need to specify the anchor type, okay? So here I have the category, and as you can see here, you have 2 options. Casting anchor, which is actually you have the mechanical anchor, or you have the post-install anchor, okay? If you select the post-install anchor, so here you have the options to connect to the manufacturer, okay? Fisher, Healthy, Speed, and also Worth. Okay, and you can download actually, you can download the anchors, from these libraries. Later, if you want to edit them, you can actually edit them as well. Okay, but for downloading them, so you need to create an account with the OB database. Okay, so you can log in, or you can take advantage of your BIM Server Center account that you have. You can log in with that account, and you can actually access to the let's say the anchor types that you have actually in this let's say post-install anchor. Okay, so here you can go to for Fisher or Hilti, okay, or Speed or Worth, okay, and then here you have actually different anchor type, which is already manufactured, okay, and then here you have different types of let's say the anchor for top location and also for embedded location, okay. So let me go back to cast in anchor here. If I go to again this view, So I want to, for example, have, if I change to this one, you see here, you will see, you have different type of anchors here. You can add the mortar, or you can, add the, or consider the spaces or empty spaces, okay? And yeah, this is actually now the type that you have. Let me come back to the original one. And then here, you can go for different type of, let's say the washer that you have here can be washer like this, or like this with 2 bolts, or it can be just with 90 degree of anchor bending, or 180, something like this. Okay, so you have all these possibilities. Okay, so let me go to select one of this, for example, this one. I will select this. And then again here, so I will say that the anchor size, let's say, is, for example, 24. And from here, it can be, let's say, change it to Euro code. Okay, I will say 25. Okay, so this is the anchor size. And then, so the grade, I will say 8.8. Okay, and then, so here you have actually the lengths of the anchor. You can modify them. Okay, so if I go there, so here you can modify the anchor length. For example, if I say 200, okay, so you can, just decrease it, or you can increase it. Okay. Okay, and also you have L2, but L2 actually is working with this one. Okay, so here you have actually L2, and also you have the D and H. Okay, but for this one only I have this one. Okay, so let me just accept this. So this is the anchor location, and then so you can actually just as simple as that, you can run the analysis. But for running the analysis, I can go to the analysis. Okay, so here you have different options, for editing, the operations. For example, if I go to this view, let's say XY view, assume that here you want to make the plate, something like this. You want to go for chamfer, okay, something like this. So here you have the options actually to modify the corners of the plates. Okay, you can click on that, and then here you have the base plate again. Okay, so here just by clicking on the add corners, so here you have the H4, H1, okay, and 2 and 3. So then here you can say that H1, so the let's say you can use the chamfer. So you have different options. Okay, you have the notch, you have chamfer, bevel, round, or arc. Okay, if I go to the chamfer, for example, here I can specify that 50, for example, or maybe 100. Okay, something like this, or maybe even more, 200. Okay, so 150. Let me select this one. Okay, and then so you can just copy. Okay, so this is 2, 3, 4, as simple as that. Okay, so you have it. So now you can, let's say, go to the analysis. So under analysis here, let me just go back there and go to the view option. I want to see it in the solid view, and then analysis. Okay, so here you have the load cases. Okay, so if I go there, you see this load cases is coming from CYPE 3D. Okay, if I go back to CYPE 3D, and if I go to the forces, and let me just go to forces. Okay, you see here I have actually a few load combinations. Okay, so here as you can see, I have 1, 2, 3, 4, 5, 6, 7 load combinations. But whatever I can see here, it is only one combination. Why is like that? If you go to generate from the BIM model, okay, so here the software tells me that, okay, you see here N, VY, VZ, MX, MY, and MZ. Okay, so all of them are set by default as 2. If you have the shear less than 2 kilonewton, okay, so the software filter for you. Okay, so you should not actually focus on the unnecessary combinations. Okay, just you need to go for the let's say critical combinations. Okay, and also for the moment, whatever is less than 2 kilonewton meter, the software filter for you. If I just say here, let's say I say 0 and 0, okay, and then accept. And again, if I go to load cases, you see here, all of them, I have it. Okay, so you see, this is again a brilliant option that you have just to go for critical combination, focus on critical combination. Okay, so you don't need to waste your time to find the critical combination. Okay, so let me just go back there, and then so here I will say whatever is less than 2, so just filter for me. Okay, so that's why here I can see that, this is my critical combination. Okay, and then accept. Sometimes you can also, let's say, for example, here, you can set it as default for yourself. Okay, so for example, here you can say 0 and set it as default. So later, after, I mean, maybe tomorrow you want to open the software, so this is only 0. If I go to here, maybe you want to see, all the combinations. Right now, you know which one is the critical combination, but you can, let's say, deactivate whatever you don't want to be included to your analysis. Okay, so here you can uncheck them. Okay, so you have all these possibilities. Okay, let me go back there, and then so here I will say 2 and then 2. Okay, accept. So if I go to here, I have only 1 and then load. So here I have actually now the axial force. You see here minus 1,697. And here also you have the huge moment. It's about almost 18,000 kilonewton meter. If you go to CYPE 3D again, okay, so you can look at the envelope, okay? And then here, so you can look at the, for example, axial. Okay, so here you can look at the axial. And then here you can see that, let me make it smaller. Okay, so you can decrease the, you can see here, this is actually now minus 1,697, okay? And if you look at the moment also, okay, so here also you have the huge moment. Let me just again make this one, okay, smaller. So you can make it smaller as well. Okay, you see here, you have the minus 17,878. Okay, so it means you have the same forces here. Okay, and then accept. So it is already confirmed. And then you can actually now just run the analysis. So here I have a huge, let's say, load. Maybe later you want to add some stiffener, okay, or maybe some stiffening plate, okay. So we will discuss it. Let's go ahead with this first to see actually the behavior of the connection. So by looking at the form shape of the connection, and then so we will take proper action. Any questions so far? Please let me know. No question? Okay, so let me just, you can play with the meshes to increase the analysis speed. Okay, so because whatever the mesh sizes are smaller, so you need actually to wait more to run the analysis or complete the analysis. But anyway, so I didn't pay attention to that for now. And then, so I'm waiting for running the analysis, or you can cancel the analysis and then, so you can do some modification. Okay, let me for demo purpose, just cancel this. Okay, let me just cancel this. And then just for demo purpose, okay? So you should not actually change this loads here, okay? But I want to just come up, with smaller loads. Let's say, for example, here I will say minus 100, okay? And then here I will put, for example, 200, okay? And then accept, and then let me just rerun the analysis. until the analysis is running. If you have any question, please let me know. Okay, so now here, the analysis is done, and then here you have actually the color coding of the utilization ratio. Okay, so first of all, you can look at the colors that you have here. For example, here I have the let's say this pink or magenta color. Okay, and then here you can just look at it. So it means that the 100% of the capacity of the anchors is used. Okay, so which means the anchors actually uh, you need to think about it. Okay, so it's not failed. If you have any failure, okay, so the software here shows you. Okay, so which means the capacity is between 80 to 100, and if you look at here, the maximum capacity or used capacity for the anchors is 82%. Okay, which is not bad. Okay, but if you want to, let's say, be in a safer side, so you can increase the size of the anchor or increase the length of the anchor, or you do something. Okay, or maybe you can actually add the shear key or something like that. And then so if you look at the plate, okay, so here you see the plate color is green. Okay, and then if you look at the utilization ratio color coding, so it is 20. Assume that the maximum used capacity of this plate is 20%, so which means this plate is over designed. You can decrease the size of the or thickness of the plate. And here also you have this welds. Okay, you see you have actually this weld, which is here, is getting actually blue, but this weld getting green. Okay, again, these two welds are over designed, because for the green one I have the maximum use capacity as 20%, and for the blue one I have the maximum use capacity of 40%. Okay, still you can optimize this weld by decreasing the size of the weld. Okay, so let me just play with the thickness of the plate. But before doing this, if I go to the one misses stress, you see here you have the stresses, and this is actually because of the moment that I have. If I go to the scale deformation, so let's say I will go to 50, let's say, even more. You're completely free actually to just increase the scale to see actually the behavior of the connection. Okay, so here, as you can see, you have actually this is the behavior of the connection. Okay, and also you can look at the strain. So the problem occurring here because you have a huge moment here. Okay, so you have a let's say 200, the thing that I applied, 200 kilonewton meter moment here. Okay, and also you can look at the displacement. Okay, so here you can look at the displacement, and you have the, again, legend of the displacement as well. Okay, let me go back to the connection. I can go to the model, and I will go to 3D view. I can decrease, just click the on the base plate, and then here I can decrease it, for example, to 16. Okay, just as simple as that. And then maybe here I can, just increase the size of the base plate. Just I want to again show you, the workflow of this software. So here in the, let's say, X direction, I will make it as, for example, let's say 2000. Okay, so I will make it something like this. And then if I go back here, so I want to add some member here. Okay, so here you have the bar. Okay, so you have the, we call it bar, just click on that. And the bar is here. You can specify the bar grade and also the material. Okay, so the material, maybe I can use, let's say, the I-beam section. Okay, so here I will go to select the UB again. And from here, I will select this one. So here, this is the UB. Again, you can take advantage of the transparent view. Okay, I will go to this view. The UB is here. And also you can increase the length of the bar. Okay, so for example, here I will go to 750. So this is the bar length. Okay, so here I have it. And then from here, I can rotate it. Maybe here I can rotate it about the y-axis, which is here, okay, by 45 degree, sorry, minus 45 degree. Let me put it 45 is okay. Okay, and then so I can shifted in the Z direction by, for example, let's say, let me try 200, more 400, okay, and a little bit more 500, okay, and then so in the X direction, also I will move it by, for example, 200, 400, okay. So this is the thing, and let me also a little bit more increase the length of this member, okay? And then from here, let me take this one as 370, okay? Just to have it something like this. So now I have actually now this beam here. And if I go back to, let's say, section solid view. So right now, as you can see, this is actually now the section which is penetrating again to the plate and also to this column. Okay, so what can I do? You can also from here, you can actually now make it more, okay? For example, like 60 or whatever you want. And again, I will use adjust bar, okay? Just click on that. So the first one, I will say that this is adjust bar. Okay, so here you have the initial and final end. Okay, so let me adjust it with the column first. Okay, so here I will say that adjust with the P1. Okay, and then so the nearest face. Okay, so here I have it, and then here I will change it to, let's say, bottom flange or top flange. This is the bottom flange. Okay, it should be bottom flange. Okay, so here I adjusted, as you can see here. Okay, and then I can add the weld as well. Okay, so here I can simply add the weld here, and again, maybe for this weld, I will go for 6. So here, actually, no, you have the different type of welds. Okay, you have the throat weld size, you have the leg weld, okay, and also you have the butt weld or penetrated weld. Okay, so you can specify again by yourself whether you want to go for um, evaluating, the size of the weld based on the throat thickness or leg size, or this is butt weld, which is actually just penetrated between two elements. Okay, so here I'm using actually the throat thickness. Okay, and then so I have this one, and then just take a copy of this. Okay, so I will just take a copy of this and then put it here. Right click, copy, and then here. Okay, so this one, it should be let's say final end, and then I want to break it with the end plate, okay? Or let's say base plate. You see, you can come up, with this one very simply. And again, so you can run the analysis, okay? So let me just go back to analysis and again, run the analysis. Hopefully you got the idea, at least, from this short explanations, how free you are to put different operations around the nodes or analytical node that you have. Okay, let's just finish the analysis. Okay, so here you have it. And then you see right now, so it says that some of the checks have not been verified. Okay, so if you want to see that, which means you have some failure, okay, you can actually, look at here. Okay, if I come here, so here you have actually some problem in adjustment to top flange, okay, which is this one. You can read it. This is about the fillet weld, okay? If I just rotate it, if I go back to here, and then so you can actually look at the failure that you have, okay? So it should be, let me just go there once again. Okay, and then from here, I can read it. Okay, maximum angle of the fillet weld, okay, according to Eurocode, it should not be, let's say, greater than 120. Okay, so that's why here actually no, I have the problem actually no with this weld. Okay, so the software again gives you the source of warnings or error. Okay, but again this one just I created in any let's say arbitrary direction just to show you the the workflow. Okay, again you can look at actually other result like stresses or strain and also the form shape. Okay, so you can also do the stiffness analysis and also buckling analysis. Okay, so simply you can just run the analysis of these two options. Let me just, we have another 1 hour. Okay, let me show you the sheets as well, and then I will go to another connection. Okay, for buckling and stiffness analysis, you can try by yourself. Okay, so the main thing here in CYPE Connect Steel is to understand how to come up with the final configuration of your connection. So the analysis, only analysis. Okay, so if you have any problem or issue with the buckling analysis or stiffness rotational stiffness analysis, so just let me know. I will come back to you as soon as possible. Okay, so here we have actually now 3 steps. Okay, the first one, I just finish my connection model, and then I analyzed it. Okay, so after satisfied with the analysis, so then I will go to the sheet to generate the drawing. If you want to generate the drawing manually, okay, so you can go to 3D scene. Here you have it. Okay, and then here you have the option insert. Okay, you can click on this, and then here, for example, I want to place the first drawing. Okay, so just like this. Okay, so I can, let's say, zoom in, zoom out. Okay, just like this. Okay, so you can press shift and you can rotate it. Okay, so assume that actually no, this is the view that I want to generate the drawing. So just click somewhere here, and then so here you have it. Okay, just click somewhere here, and then you have it. So still this command is active. I can go to create another drawing. Okay, so just click here. So this time here you have the scenes. Okay, so here you can go for example, create the drawing for base plate only. Okay, so here you have the only base plate, and then here you can change the view. Okay, so you can let's say go to normal image or hybrid image or monochrome image or vector image. If I click on this one, you see here you have actually now the vector image. Okay, and you have the image quality. You had when editing, when printing, you have the background. Okay, so solid white or transparent. Okay, so this is all after printing. Okay, nothing, let's say, complicated, and then just click here. Okay, so then here you have actually now the drawing of the base plate. Again, I can go to here. So this time I want to put something like this, but this time instead of the base plate, I will say all the connection. And here you have the 3D view, front elevation, side elevation, or plan. Okay, so let's say I will go to front elevation. Okay, so here you have it. And again, from here, from the mode, I will go to vector image, and then here I have it. Okay, so this is the manual way to add the let's say the drawing for the connection. Then let me go to delete the drawing that I created here. Here you can see the editing option. Okay, so you have the edit the drawings. Okay, for example, here if I click on edit, I can click on this, and again you have actually now this dialog box to edit your let's say connection. For example, here I can go to side view and then just click here, and then here you have it. Okay, you can let's say go to copy it. Okay, for example, I want to copy this one, just click on this, then do right click. Okay, and then you can select from here, and then you can put it here again. Okay, you have the move option. Again, you can click on this and then do right click. Okay, and then you can, let's say, move it like this. You can rotate it. Okay, you can delete it. You can let's say modify the geometry. So here, for example, for this one, I have actually no let's say unused space. Okay, so here I can click on this, and then so I can actually now modify the geometry just like this. Okay, so I can create it like this. And then here you have actually now the redesign. So if already change the drawing, so you can now click on that, and then so it goes back to actually now to the original one. You have the mirror, and also here you have the assigned properties to each of this let's say drawings. Okay, for example, if I click on this, and then here, so you can assign the different, let's say, options. Okay, so for the lines, you can select actually different lines that you want. Okay, you can customize it. Okay, so here you have all the options actually to customize your drawings. Okay, so as you can see here, you have it. Okay, so you can go to the text. Let's say here you have different text. You can go to customize again, and then here you have it. Okay, you can go to the fill option. Again, you can go to customize, and then here you can actually fill it. Okay, and also about the dimension, so how you want to appear actually the dimensions. Okay, so here again, you can go for, let's say, the continuous line or different type of dash line. Okay, so let me just close it. Here I am going to delete. I want to delete everything. Okay, just like this, and then right click. I can use the, again, 3D scenes, and then here I have the insert predefined views. Okay, so this is the wizard. Just click on that, and then here you have this dialog box again. You can actually go for vector image, for example, and then here you have the text style. If you have the customized one, okay, so you can also select from the whatever you customize it already. Okay, but right now by default we have this. And then the dimensions again, so you have the customize option. Okay, so only the thing that I created here, it is the style 1 and style 2. Okay, so you can customize it for yourself. And then here you have the 3D view, front elevation, side elevation, plan, and also the base plate. And here you have the paper size. Okay, so you can specify the paper size, and then you can accept it. Okay, just accept, and you have all the drawing automatically. Okay, so I forgot actually now to change the scale. Okay, so you can actually now just change the scale of the drawing. If you go to edit, okay, so here you have the scale. Okay, so I can say that this is actually now 100. Okay, I should do it actually now before that. Let me just accept it. Okay, and then so from here you can again edit the geometry of the dimensions, or let's say the entire plate that you have here. Okay, so let me just again delete this one. One second. Also, apart from this wizard that you have here, also you can use the sheet composition. Okay, so this one also you can actually just come to here, and then here you have different views. You can actually let's say, preview your type of connection that you have. Okay, so here you can just review them. So if you are satisfied with this type of drawing, okay, so you can just bring it to the drawings. Okay, so now let's say here I have actually this one, and it is nice, so I'm satisfied with this, and then so I can select all of them and then accept, and then so I can bring it here. Okay, so this is actually the drawing that I have here, and then so I can again change the scale or whatever you want. But let me here just move this one to somewhere here, move this one to somewhere here. Okay, and then move this one to maybe somewhere here. Okay, so I can go back here, and also I can add one, let's say with the 3D view. Okay, something like this. And then here you have the drawing elements. Okay, you have the tag option. I can go to the tag. For example, here I want to say that, okay, so what kind of elements I have. Sorry, I just forgot to tell you. Once you are using the sheet composition, okay, so you cannot, or let's say the tag, because this is already locked, okay, you cannot use the tag, okay. Let me use the wizard that I have. Let me just once again clear everything. Let me go to wizard. Okay, so here, let me just select all of them. And then the scale divider, let's say here we can go for let's say 50. Okay, so let me just go for scale 1/50, 15, 50, and then 50. Okay, and then I will accept. Okay, so here this is the drawing. So I could also change the, let's say, the paper size. But anyway, so here I have it. I want to edit this one, okay, to, let's say, normal image. Okay, so here I have it. And then, so here I have this one. Let me just bring it down. Okay, so here I can put it here. I can put this one here and then put it here. And here I can select all of them. And then, so I can, let's say, put it here. So now I can go to the tag. Okay, and then here I can specify the, different material or sections that they have. Okay, so here just I click on the tag and then you have this window. So you have actually, with different options. Okay, so you can tag it, in different manners that you have here. Okay, you can select the tags and then let me just bring it back here. We got. Okay, and then so here, for example, for this anchor, so I can, select this anchor and then I can put it here for now. Okay, so here I have this member. Okay, so you have the concrete column. So I didn't name the column. Okay, and then so you can go for the weld. Okay, so here, if you cannot see well, so maybe I can go back here and then so I can change it to vector image. Okay, so a little bit more clear. Okay, and then so I can go back to tag. Okay, and then here you have the weld. Okay, so you can specify the weld here. Okay, you can put it something like this. And then so I can just select all these elements. I can press shift to deselect whatever I don't want. Okay, and then do right click. And then so I can put it, for example, somewhere here. Okay, so similarly here, you have actually the information for the base plate. Again, you can edit the text as well. Okay, so you can, let's say, just go to edit the text. Okay, so if you want to customize it for yourself, okay, you can customize it. And then here you can go there and you can say that, for example, you want to see it with the smaller sizes. Okay, and then accept. Okay, so you can customize it. Okay, and also you can put the, let's say, you can go to drawing rectangle. Okay, so maybe here you want to come up with your own title block. Okay, so here this is actually, a big page or paper size. Okay, so here you can actually, just make it for yourself, something like this. Okay, so you can come up, with the proper title block that you want to have it. You can put your logo or whatever you want. Okay, and then you can save it as your own template. Also here you have some other options. You have the section. You can create the section. For example, here I want to create a section from here. Let's say from here to here. Okay, in this direction. And then so I can put it here. So this is the, let's say, section. Okay, and yeah, finally, you can print it out. This is the integration of CYPE 3D and CYPE Connect Steel. You can import all the information, including the section sizes and also load combination to CYPE Connect Steel to design your connections. Okay, if you have any question, please let me know. Then I will show you how you can start from scratch if you want to create any connection that you have the forces from another parties and you want to apply the forces manually by yourself. Any question, please? Okay, no question. Okay, let me close this. Okay, so here also you can see the connection. I will go to create a new one. Okay, so this time I don't want to use the information from CYPE 3D. Just click on new, and then here I will save this one. I will say, let's say training 21st May 2024. Accept. Okay, so here you need to uncheck this option. Link to a BIM Service Center should be unchecked. Okay, and then accept. So here you have the empty space. So again, you can actually now define the code by yourself. Here you can go to the section libraries. So if you want to bring, for example, our common section, which is the UB or UC, okay, so I will select them, and then so I will accept, I will bring them. And then so for creating the columns, or let's say, the sections, assume that here we want to go for having, the column to beam connection, okay? Here we want to create something like this. Here I want to put the end plate, and then so here I want to add the beam, and then here maybe you want to add the hunch here, okay? And then we can actually now go for adding the bolts, okay? And then here we can apply the loads to the beams, okay? And later maybe here also you can add some stiffener here, okay? Maybe you can add another stiffener here. Okay, so let's talk about it just to get the idea. And again, so you can try it by yourself anytime. If you have any question regarding CYPE Connect Steel, just WhatsApp me. I will come back to you at the earliest possible time. Okay, so let's go to focus on this connection type. Okay, I will go to nodes. Okay, so as you can see under node category, everything is deactivated because I don't have any node. Okay, that's why I need to create it from here. Okay, just click on that. And then here, I will say that, the overall name of the connection, I will say beam to column connection, or I will say that BC connections, okay? Or maybe I can say that rigid beam to column connection. Okay, so this is the name of the connection that I want to create. And then here you have the bars, okay? Just click on this plus icon. And again, here you have it. So I will say that this is the beam. Okay, if you have different beams, so you can say beam 1, beam 2, whatever you want. And from here, if you want to go for ruled sections, you have actually the ruled sections from here. If you want to go for cold form, and again, tabular sections, okay? And then built-up sections, you can go for taper section. Maybe for one example, we use taper sections, okay? And also timber, okay? For timber, also you can connect the steel to timber material. Let me go to select the material using this option 275, accept. Okay, and then if you cannot see, this, let's say, information, just a little bit play with this. Okay, so they will be appear. Okay, and then for the section, I will go to select the UB, for example, and from here, I'm gonna say UB. Let's say 457, 152, 52. Okay, so this is the section that I want to use. Okay, so now I'm okay with this. This is my beam. And then so I will add another one, okay, or take a copy because already I specify the section and material grade. Okay, so just to save time, I will take a copy and then I will come to the second one. And here I will say a column, okay, and then enter. So now the column is here. I need to rotate it. Again, if you look at the local coordinate system, you need to rotate it about the y-axis, okay? So here you have the angle with respect to the XY plane, okay? So just go there and say 90 degree. Okay, so here you have it. If you have the continuous column, okay, so like this, so here you can check this option, okay, continuous bar. And then so it will be like continuous. Okay, so let's accept the continuous column. Assume that you have the continuous column like this. But if you don't want to accept it, okay, so here you need to shift down the beam, okay? And again, using this options, okay? Using the translation and also rotation, you can place the beam or elements in the right locations. Let me go to continuous bar. Okay, now the connection for me right now is ready, the beam and column, and then accept. Okay, so here I have it. And then so I will go to this option and then here I will click on connection. Okay, just click on connection. Again, if you cannot see anything here because we don't have the operation right now, I can add the end plate this time. So here I want to place the end plate. Okay, so already I use the plate, I use the bar, adjust bar. Now let me use the end plate. Okay, so just simply click on end plate. And again, here you have the option to tell the software this section, which is beam, should be joined to column. Okay, that's it. And then, so the end plate is here. Okay, so now you can go to the material, let's say S27, accept. And then here you have the geometry of the end plate. So here we want to provide, some space for the welds. So that's why here you have the overhang at the top. I will go for 15, for example. Okay, overhang at the bottom. So maybe later we want to add the hunch. Okay, so I will go more. Maybe I will go for example, 150. Let me try. Okay, more. Say 250. Okay, so here I want to specify the hunch here. And then, so for the left and right, so is okay. I don't have any issue with that. And then, so I can go to add the bolts. Okay, so again, I can take advantage of this views. Okay, so I can go to this view, and then here I have it. So I will try to put one bolt. Okay, so the bolt is here. And then, so here I can say that the type of the bolt, I want to say that it is the Eurocode base bolt, and then I will go to have the, let's say 22 or maybe lesser. Okay, so I will select the 16. Okay, and then here I have the material grade 8.8, accept. And again, here I have the X direction. However, here you have the generate, again, as I showed you. Okay, so you can actually now play with this to come up with this. Okay, so for this one, I have, one tutorial on this. If you want to understand about actually know how it works. Okay, so this is the thing. Okay, I think this one. Let me just quickly discuss about it. You can also, this is another tutorial, which is actually now based on the real project for one of our clients. Okay, so you can also look at this. This is another good tutorial actually. Okay, so here you have the bolt, and then so you can go to the, let's say here I explain actually now how it works. Okay, so you can watch this video, how to design CHS truss connection in CYPE Connect Steel. Okay, let me just put one bolt here. So in X direction, so again here, I will go for 35, okay? And then in Y direction, I will go, or let's say try 100, a little bit more, 125, 150. Okay, so I will put it here, maybe 75, okay. So I will put it here, and then just copy this. So here I can come down, assume that, every 50 or 100, let's say. So here I will say 100, okay, and then copy this. So you can say 0, and then copy minus 100, okay. And the last one, again, copy minus 175, okay. So you can put it something like this. Okay, and then so take copy of all of them, okay, copy. And then here, so just you need to say minus 35. You see again, so you can select all. Let me show you. You can select all, and then just do for one, okay, minus 35, and then enter. Okay, so here you have it. Okay, so you don't need to do it one by one. And then, so let me also add some other bolts here. So I will take advantage of the last one, okay, so which is this one. Make a copy of this. Okay, and then here I will say minus 250. Let me go more, okay. 350. And just this one minus 300. Okay, so I want to put it here. Okay, and let me put the, let's say, hunch somewhere here. Okay, so for adding the hunch, let me finish the welds as well. Okay, so now we place the bolts, and then so I will go to the weld, just activate the weld, and then here you have it everywhere. Okay, so here automatically, and here I will specify as 6. Okay, and then here also 6. And okay, so let me go back to geometry of the plate. So here, let me make it as 16. Okay, so here, make it as 16. And then, so I will go to add one plate. Okay, for adding the hunch, I can add the plate. Okay, so just go to the plate. Again, the material, I will say that 275, accept. And then the thickness of the plate, I will also go for 16. Okay, so the plate, as you can see right now, is here. Okay, so you have different options to place the plate. Okay, so here you can go to attach. You can say that attach to the beam, for example, bottom flange. Okay, so which is somewhere here. Okay, or you can say that perpendicular to beam. Okay, let's say top or bottom flange. Okay, so if I go to this view, okay, so right now here I have the location of this end plate. And if you look at here, let's say, look at here, this is exactly at the middle. Okay, so I will go to this view once again. And then, so I will say that the size of the, let's say the hunch, let me try with 400 by 600, something like this. Okay, and then let me replace it. Okay, 400 by 600. Okay, so I will shift it again in the X direction. Okay, so let's say I will shift it by, let me try by 300. Okay, a little bit more, maybe 400. Okay, 370. Okay, assume that here, this is the location of the hunch. Now, simply I can, again, go to trim the plate. Okay, so here I can trim the plate here. Okay, so if I go to trim plate, so here I have the plate 1, okay, and then trim with the beam bottom flange. Okay, so here I can trim it. So I can also weld it. So simply I can weld it here. Okay, again here I will go for 6. Let me go back to the plate. So here I will change it to hunch. Let me name it as hunch. Okay, accept. If I go back there, so let me just make it as hunch. And this one, which is actually the hunch here, I will make this one a little bit more, let's say 500. Okay, so just to put it here. And again, so having this view, so I will take a copy of this. Okay, just copy. But this time I will say that I want to cut it with the plate, okay, with the end plate, which is the front one. Okay, so here. Now I can use the modify corners again. Okay, just modify corners. And then here it is the hunch. Again, here you have the 3, 4. If you want to see it, you can go to view option. And again, here you can just go to transparent view. So here 1, 2, 3. Okay, so you need to focus on edge number 3. Okay, and then here you can say edge number 3. Okay, and you can use the, let's say, bevel. Okay, dimension 1. Let me try with, for example, for now, with 300. Sorry, 200, a little bit more, 230. Okay, so here I can put it here, and for this one, let me go for 400. Okay, so you can come up simply with this hunch. Okay, so here you have the hunch, the location. If you want to add the stiffener, okay, assume that here you want to add the stiffener here and here. Okay, again, you can use the plate option. Okay, so here you have the plate. Just use this one. And as you can see, the plate go to Z, and then we'll shift it by, let's say 225, okay, 225. So why actually, I was looking at this because, the location of the plate is exactly at the middle of the beam. So that's why here I'm looking at the UB 457, okay? So divided by 2 almost gives me 225. And then so I can, simply put it here, okay? So if you want to adjust it a little bit more, okay, so here I can say that 200, let's say 20. Okay, so right now, this is actually now the location. And then I can go to view option again. So I will go to transparent view. So here I have it. And then so I need to go to X direction. Here, I will say that again here, I have actually now the UB. So here also I will go for 220. Let me try, or let's say 450. Okay, so now I need to put it somewhere here. Okay, so I will say 440 and lesser 30. Okay, and let's say 20. So if I go to this view, so make sure that this is well placed, okay? So here, I placed it here, okay? And then so I can a little bit shift it in Y direction just to put it, in another direction, okay? So let me go to Y direction and then I will shift it by, let's say here, 75, okay? So I can go for 65, 55, okay? So here, just a little bit more, 53, and then 54. Okay, so I can put it here. You can also, always specify a little bit of space, just from, let's say, practical point of view. Okay, and then so here I will make it lesser, let's say 75. Okay, and then here, let me go with another 25, which is, let's say 79, sorry, 54, 24, okay, 34, 40, 42. Okay, so I will put it here a little bit more, maybe I will put it here, okay. Okay, so I want to have this one. And then so also I can specify, let's say here, I will say that sorry, this one I will say S1, which is Stephen S1 or ST1. Okay, so this one, let me delete it for now. And then so I will go for modify the corners. So here I need to just cut it here and here. Okay, so again, I will say that ST1, corner 1 and corner 2. Okay, so here I will say corner 1. I will go for chamfer. Okay, so this one, maybe I can go for 20. Okay, and then add a copy another one here, and then here you have it. Okay, so I can go to add the or copy this one. So this copy this. Okay, so I will just select this one, and then here you can put it actually now to the end. Okay, so this one is the ST2. Sorry, this one is ST2. Okay, And then, so whatever I have here, let me also specify for ST1 as 275. And then here is 275. Okay, so the thing that I need to do, so here, just I will say, let's say in the Y direction, let me go for minus 40. Okay, and then again here, I will go to this and take a copy of this. Okay, again, I will put this one to the end using this option. Okay, so here should be ST2, and then here it should be corner 3 and 4. Okay, so here I will remove this one. So I will change it to 3, enter, okay, and then copy. Okay, so here you have this stiffener. If you want to see it, you can actually now see from here. Again, you can, just take a copy of this, okay, and then, just, let's say model it, okay? So I will say copy, okay? So this one, this is the ST3, let's say, ST3, okay? I will put it at the end, okay? And also this one, I will make another copy, and then, so this one, I will say edit, ST4, okay? And then add, and then put it at the end. Okay, so the only thing that I need to do, so here I need to say minus, okay, 25, and then here also minus, okay, so here you have actually now a stiffener here, and again, so here you have this one, so this, again, I made a copy of this, okay, so I will put it at the end, but this is related to ST3, okay, so I will bring it up here. And then, so this one will be ST3. So as you can see here, already I adjusted. And then, so I will go to this one and then copy. And again, so I will put it at the end. And this is related to ST4. Okay, so here, so simply you can place them. If you want to see the solid view, so again here, you can see the solid view here. Okay, so now you need to go for the let's say welds. Okay, so you can go to the weld. So here I can say that ST1, you can with the plate, okay? ST1 with section column. Okay, so you can start with the top flange. So you can see from here, okay? Is here. And then, so you can again go for 6. And then, so make a copy of this. Okay, and then here, this bottom flange, which is here. Okay, and again, another copy. Web. Okay, so here you have it. And again, go to copy this. Let's say copy. So here it should be ST2, which is here, the web. Again, copy. ST2 top flange, copy. ST2 bottom flange. Okay, so here you have this. And again, copy. So it should be ST3 bottom flange, copy. ST3 top flange, copy. ST3 web. Okay, so here you have it. Okay, and again, copy. ST4 web, copy. ST4 top flange, and then copy ST4 bottom flange. Okay, so here you have all the, let's say, operations. So similarly here, you can, add the, let's say, the stiffener to the beams as well, if you want. Okay, so once you did this with this, so then you need to go to the analysis. Okay, so here you have the opening. Let me also show the opening. Assume that you have the opening inside the beam. Okay, so you can click on the opening, and then again, the section is the beam and also the web. Okay, and the type of the opening is circular, and here you have the, let's say, XY, which is the, let's say, the origin of the opening right now, as you can see, is here. Okay, so you need to shift it in the, again, X direction. Okay, so I will shift it by, let me try 300. Okay, so here you can see. So let me make the thickness by 100, or say the radius. okay? And here I will go for 400, let's say 500, okay? So I can put it here. And a little bit more, maybe 150, okay? So you can put the opening inside the members as well. Okay, so what else? By the way, for the stiffener, so also you can use this one. So I showed you actually know the plate, but here also you can use the stiffener as well. Okay, so if, for example, if I want to add the stiffener to the beam, okay, so you can, just click on this option, and then here you can say that section beam, okay, and then the material is S27, okay, and again here you can specify the section beam, okay, on both flanges. Let's say if I go to here, okay, so here I have the section beam and then position, okay, to the beam here, and then so I need to position it maybe top edge separation, bottom edge separation on both flanges in the direction of the, say, local, okay. So here I have this one, and then so I can displace it in the X direction again by, for example, 500, let's say, or a bit more, 600. Okay, so I can put it here. Again, if I go back to view option, okay, so here, this is actually now the simple placing of the stiffener. Okay, so you can do it also with the column as well. Okay, and again here you can change the weld size. Okay, so here you have it. Any questions so far? Okay, so then let's continue. So I will go to analysis. Okay, assume that here. So I finished this one. But remember one thing. So you can always actually export your final connection configuration. Okay, so here I can export it. Okay, so here I will say that rigid beam to column, I will say connection 1. Okay, and then accept. So already actually now I have it. If I go to import, you see here, it detects actually now the same geometry. So what does it mean? Here, let me save the model. And then you see here, I want to remove everything, okay? Let me just accept this and then take a copy of this, okay? So here, and then if I go to connection, so let me here remove everything. Okay, assume that you have actually this one. Already you have actually now your template manager. Okay, you can go to import the similar geometry of the connection that already you created and you have. Okay, so here you can click on that and then the software automatically detect this. Okay, so here you have this similar geometry. Okay, you can accept it, just click on that and then accept. Okay, so everything will be placed automatically. Okay, so that's why, for every connection that you created, I suggest just to import it, export it, okay? Just to go for, let's say, connection library, okay? So here you can create your own connection library, okay? And then, so whatever you have, so it will be appear here, okay? So let me go to the analysis. So since we modeled this connection from scratch, so I don't have any BIM generate model. Okay, so if you remember from the first example here, I had one additional item or option, BIM generate model. Okay, but right now I don't have. If I go to load cases here, only I have one load case. If you want to add more load cases, okay, so right now I have the LC1, I can go to LC2, LC3, LC4, LC5, okay, and then accept. Then you can go to the load, okay? So here you need to specify one member as the main member or bearing member. Okay, so I will say that the column is the main or bearing member. and then we can go back to the beam. You see here, you have the several combination or 5 combination that I just created here. And then you can add the load manually by yourself, okay? So assume that here I want to apply the 10 kilonewton axial force. So you can look at the, let's say, the provision of the forces, okay? So for Vy, okay, so here you can see that, the location of Vy, it is in that direction. But let me add, some vertical shear force, okay? So here you have the Z, that's why here you need to say minus, for example, 22. Okay, and then so this is the torsion, Mx is the torsion, and My is the major axis. Okay, so here, let's say I want to add 35 kilonewton meter moment, and Mz is the minor moment. Okay, so here you can see the Mz is around the z-axis. Okay, so this is the thing, and then let me accept it. I don't need L2, L3, L4, L5. Okay, for now, just accept. And again, I can go back to load cases, and then I will delete, let's say, this one, this one, this one, and this one. Okay, and then accept. So only I have this combination, okay? And then accept. So now you're ready for running the analysis, okay? Let's say here, previously we run the stress analysis, but let me also run the buckling analysis, at least see the buckling analysis. Okay, done. And then here, so you need to look at the buckling factor, okay? For example, here, you can see you have actually the buckling factor with 56, okay, which is much higher than 1, okay? So here also you can critical load factor 56, okay? So you need to take care about this, okay? And then at the same time, so you can go to look at, other modes, okay, of the buckling. Okay, let me go back to stress strain analysis as well. I can run, together. Okay, and again, so right now, as you can see, everything is in green color, which is over design. Only this bolt, also this bolt is over design. Okay, so simply you can, just check. For example, maybe you don't need to have this stiffener here and stiffener here. Okay, and you can look at the stresses, just like this. You can look at the strain. Okay, and also you can look at the deformation. You can increase the scale. Okay, even you can go for 1,000. Okay, something like this, just to feel how the connection actually, is behaving. Okay, it's like this. And so finally, you can go to sheets. Okay, so here you can go to the sheets. And again, here you can generate the drawings, okay, which already we discussed about it. Okay, let me go back to analysis and also show you rotational stiffness. Right now from here, you can, go to stress strain, okay, analysis, or you can look at the buckling analysis. So here I can go back to, let's say, proper scale for buckling. Okay, again, stress, okay, stress strain analysis. Okay, so here you can look at the stress strain analysis. And also you can do the rotational stiffness analysis. Okay, so once you click on rotational stiffness analysis, so here the software says that you have not selected the bars for which the rotational stiffness is to be calculated. Okay, so you need to go back to, let's say, the loads. Okay, and then here you have the rotational stiffness. Okay, so here you need to check the beam, for example, to be as the member that you want to see how it behaves, because right now the column is fixed or bearing member. So we need to check the capacity of the operation and plate the bolts, the belts, because of the applied load to the beams. Okay, so that's why I will accept this one. Okay, beam, the load case to be considered for the rotational analysis have not been defined. Okay, so maybe here I need to go to rotational stiffness, okay, and then here I will add, let's say, I will say load case 1, okay. So here, actually, this is not that matter, okay. So here you need to add some, let's say, arbitrary loads, okay. It's not that matter because for the connections, actually, no, we have the capacity, okay. So let me just accept this and then run the rotational stiffness analysis. And then, so we know that this type of analysis is a rigid connection, okay. So this connection, we are using the end plate and the software should come up with the rigid connection behavior, okay. Let's see. But not all the connections are simple like this to understand the rigidity of the connection, okay. Sometimes, for example, you have some connections maybe like this. Maybe here you have the column, and then here you have the, for example, one beam here with a little bit gap. And then here you have the fin plate or cleat. Then you have a number of bolts. Okay, and maybe here you're adding, some member, stiffening member here. Okay, so then you don't understand actually no. So what is the behavior of this connection? Is rigid or semi-rigid or hinge? Okay, so that's why you can run the analysis, stiffness analysis, to understand the behavior of the connection. By the way, before running the analysis here, you have, design option. Okay, usually we don't recommend you to change the parameters that you have here, but you have some parameters that, in some special cases, maybe you can change them and, just to have the faster analysis. Okay, so whatever right now I'm using, it is all based on the default parameters. So do you have any special type of connection that you have difficulties with design of the connection using, I don't know, your hand calculation or a spreadsheet? And how did you find the CYPE Connect Steel, whether useful for your design jobs, or what is your feedback, Ms. Kelly, Mr. Jin Hao, and Mr. V? Any comments?
Yeah, Mr. Khalid, at the moment, I can't comment more until I really hands-on and try on it first. Yeah,
Correct.
yeah, I will definitely try on one of our connections details.
Sure.
Just from from the from your presentation, right? I can see that it's actually we have to really put in those dimensions and stiffness very precisely.
Correct.
Yeah.
Correct. Correct.
I understand that it actually linked to the shop drawing, which
Mhm.
we need the accuracy there. Yeah, but it also time consuming lah. What I can tell is it takes about at least maybe 20 to 30 minutes. Yeah. Anyway,
Yes,
yeah.
but
I
yeah,
will
but
try. Yeah.
yeah, please, please.
Mm.
Yeah. Okay. In terms of, let's say, being time consuming about the connections. Yeah. So I agree with you, but you see, you are working actually, with a software that you can come up with any connection configuration. Okay. So
Yeah.
I'm sure, you are using Idea Statica as well, right?
Yeah. Yeah. Yes.
Yeah. Okay. So this is just like Idea Statica. Okay, and yeah, in Idea Static also you need to come up, with let's say, adding the members or plates or whatever operation that you want to add it to your connection to come up with the final
Yes, correct. Quite
configuration of the
similar.
connection.
Yeah. Quite
Yes,
similar.
yes, yeah, the same, almost the same concept, yes. And yeah, so this is the thing, okay. But the good thing that you have, so you have the template manager or connection library, okay. So once, because usually, I mean, the connections, are repeatable, yeah. So you can save it, and then so in future, if you have the same type of connection, again, you can recall it, and you can assign the properties or configuration of that connection with all operation in the new connection that you have. Okay, and then yeah, you don't need to spend even, even a few seconds. Okay, so you can have your connection. So right now we did the stiffness analysis, and as you can see, it gives us actually the stiffness or rotation, or let's say moment rotation capacity or behavior of the mem or connection in XZ plane and also in XY plane. So XY plane actually is the major plane, okay, which is we have the MY, right? And if you look at the XY, you see it is let's say extremely rigid. Okay, so here also you can see that this is the rigid. But in the XZ plane, which is actually in this plane, the minor, okay, you have this semi-rigid due to having this kind of bolts and this bolts. Okay, it means that if you apply the load in this direction, okay, so the behavior of this let's say beam having this type of connection is semi-rigid, is not rigid. So which means it a little bit flexible. Okay, and you have actually this information here. You have the the initial stiffness. You have the let's say the inelastic stiffness as well. Okay, so you have this kind of a stiffness, which is let's say something like this. Okay, so here you have this one, and this one. Okay, so I think that's it. Okay, and again, so you can go to the sheets, and from here, as we said, so you can use the sheet composition or 3D scenes. Okay, and again here you can just you see how many plate you have. So all this let's say information will be generated. Okay, so here I can just click on that. Okay, and then I have the plate information. Or you can go to sheet composition from here. Okay, and then here you have all these drawings at the same time, so you can bring it to, for example, A3 size landscape. Okay, so something like this. Okay, and then you have it. Okay, so yeah, this is from my side. If you have any question, please let me know. Otherwise, we can end up the session. And yeah, so always also you can go to, let's say, have the hunches as well, okay? Or sorry, the PB sections, okay? For example, let me, if I go back to this connection, okay? So you can make this connection as the PB type connection, okay? So for example, this one, you can say that the material is 275. And then here, I will go to name this as whatever it is, okay? And here I will say that the initial depth, for example, I will go to 600, and the final depth I will go to 300. Okay, something like this. You can come up actually now with the hunches as well. Okay, and from here also you can rotate it about the y-axis, for example, 15 degree minus 15. Okay, something like this. Okay, and then so you can accept it, and again you can go to connection. Okay, and here you have actually the base plate like this. You see, everything again will be updated. Already I put this hunches, this end plate, and then so just by rotating this, so still you have everything there. Okay, so you can come up with the PB type sections as well. Okay, so that's it from my side, and please let me know if you have any question. Okay, that's it. We can end up the session. Any question, please let me know. Use the software, and I'm sure, after 1 week, 10 days, so you will be master in software, in the software. Okay, thank you so much, and keep in touch. And any question, yeah, just WhatsApp me. Thank you so much.
Thank
Have a
you.
great day. Stay safe. Bye-bye.